In this video we will create a simple LabVIEW application, and we will use the state machine principle. So the state machine principle in LabVIEW is a basic principle which you can use to create basic or advanced applications in LabVIEW. And if you are using these basic state machine principles, you can easily create larger applications, and you can also easily extend the application with more features. So here you see the application that we are going to create in this tutorial. It is a basic application where you have here a numeric indicator, a button, and when you click on this button, I will use the random generator to generate a number between 1 and 6 that will be shown here, and also I will show the same value here in the plot. So here this plot or chart will show values between 1 and 6, and when you click stop, the application will stop. So basically this is a basic application that you can easily create in LabVIEW, but in this tutorial I will create this application using this state machine principle. So here you see some part of the code for this application, and we will create this application step by step. And a state machine in LabVIEW consists of a while loop, which you have here, and inside the while loop you are creating or using a case structure, and inside that case structure you have different states or events, and one of the cases is a so-called event handler. And inside that event handler you are going to use an event structure, which is also a structure that you find in LabVIEW. So basically a state machine consists of a while loop, a case structure, and an event structure. So now I will demonstrate how to create this basic application step by step using this state machine principle. So now I have opened the LabVIEW programming environment. So here is the startup window. I just go to File, New VI, and then you have the front panel and the block diagram. So then I start by creating some part of the front panel or the graphical user interface. So we need a numeric in order to show the value from the dice. Then I need a button to stop the application, and I need another button that will throw the dice. So when I click on this button, I will use the random generator, and the value from the random generator will be presented here in this numeric indicator. So this is a numeric control. I can either right click on it and select change to indicator, or I can find the numeric indicator here directly. So this is a numeric indicator, this is a button, and this is a stop button. And since this stop, the button says stop inside the button, and then I don't need this label on top, so then I just right click on it, visible items, and remove this label. As you remember, there was also a plot in this application, but I will start with this basic application, and then I will extend the application with the plotting feature later. But let's start with this simple application. Here we have a numeric indicator, which will be the number from the dice. So then I just rename it to dice, and this button will illustrate that you are throwing the dice, and then the value will be presented here in this numeric indicator. So then also I can change the value here to throw the dice. And then I can also here right click visible items and remove the label like this. So then I have my first version of the graphical user interface. Then I will just click Ctrl S in order to save my application. Then I just create a folder here on my local drive, LabVIEW state machine, and I then just name my application days application or something like this. So now I created the graphical user interface. Let's start creating and using this basic state machine principle in our block diagram. So then we start with a while loop. So then I just right click here, and on the structures we have this while loop. So I just make a while loop like this. I can also right click on it, select visible items and label, and then you see this is a while loop. And inside the while loop I need an event structure. So I put it just inside here, like this. So this is an event structure. Sorry, I know I took the wrong. So here, right click, structure, and case structure. That's what I need, a case structure. So I can do the same here. I can right click on the border, select visible item and label, and then you see this is a case structure. So now we have a while loop, a case structure, and then here on the border of the while loop, you just right click and then select add a shift register. This shift register will be used to switch between the different states or the different cases in the case structure. So then the first case in our case will be to initialize our graphical user interface, and then I just use a string here, a string constant. I put it here on the left side of the while loop, and here I can just type initialize like this, and then I connect this text constant to this shift register like this. And the next step is to take the output of this shift register to the question mark on the case structure, and then I can just put it like this, so have it on a straight line. So now we have started to create the basic fundamentals of this state machine. And then the next step is to change the value of these cases in the case structure. So I just click here with my mouse and go to the false. This will be the default case. Then I change the name to initialize like this. And inside this case I will not do much. I will just initialize this indicator, and I will set it to 0. So then I can just right click here on this numeric indicator. So I see I have my object here on the block diagram. Then I can just right click on it, create a local variable which I put here in the initialized case. Then I just right click on it, create a constant, and then when I start the application, this numeric indicator will have the value 0. So that's the initialized case. The next now I want to create the case that will be executed when I click on this button. And I have this button here, and I have the object of this button here. So then I just create a new case here. I can use this true case. I can change it to event handler. Of course, you can call the name here whatever you like. I prefer to call it event handler or wait case or whatever. And inside this event handler case, I will just right click here, select structures, and then here I will use this event structure. So then I just place this event structure here inside this case called event handler. And then here in the left upper corner you have this symbol. I just right click on it, create constant, and set, instead of -1, I set 100 milliseconds. So when the program is inside this case, it will wait for 100 milliseconds. And if nothing happens inside within 100 milliseconds, it will just wait here for something to happen, typically when a user click a button, etc. So then next I want to create events for these two buttons, this throw button, which is here, and this stop button. So let's start with this throw button. Then I just right click on the border of this event structure. I just right click here on the border, select add event case, and then I select my button that is called throw dice, and then select the proper events, value change. Then click OK, and then you see a new event handler for that specific button has been created. So then I can just put the button inside this event handler, and then I need to write or connect what should happen when the user click on this button. So then typically the code will go inside here, and then typically I want to go to a specific case. So then I can just copy this one and then type throw dice or something, and then I can connect this one to this, to the right side of this shift register like this. So then next I need to create a new case here in the case structure. So then I just right click here on the border of the case structure and select add case after. And then a new blank empty case has been created. So the first thing I need to do is to name it. So then the name should be throw dice like this. And then inside here I should use the built-in random generator to generate a number between 1 and 6. So then I just right click here, find under numeric, I find this random number generator. If I click on Ctrl H, that you see it has two inputs. You define the upper bound and the lower bound. So the lower bound will be 1 and upper bound will be 6. And then a random number between 1 and 6 will be created here on the output. I can also right click to select this label so you know what kind of function it is. So then I just right click here on the upper bound, create constant, and then it should be 6. And then here on the lower bound, right click, create constant, and this should be 1. So now on the output, so the output of this function should be wired to this numeric indicator. So then I just wire this output to this one. So you know, since this will be a number between 1 and 6 and it will be only integers, since this is a dice, I don't need to use a double here. So then I can right click on it, select representation, and just use a int 32 or an unsigned 32 or whatever, just using an integer value like this. And since it cannot not be a negative number, I can also select unsigned 32 like this. Or you see also the output here will be a 64-bit integer in general. So then we have created the feature for generating a random number. And also here you specify the data type that should be the output of this function. So here is a U64, and then I can typically use the same here. So then under representation using U64, and then the output here will be the same data type as this numeric indicator. And now when we are finished with this one, we should go back to this event handler case, which you have here. So then basically here on this shift register you just right click, create constant, and then type event handler like this. So now we are almost finished. One thing I forgot in here in the initialized case, so the start value on the dice should be 0, indicating that the dice hasn't been thrown yet. And also here you see there are different data types, so then I can just change the data type. Since this dice will be a number between 1 and 6, and this is a U64, then I can also use the same data type here, representation, and U64 like this. And now when I set this start value to be 0 here, then I should go to the event handler case. So then I just do the same here. So I just right click here, create a constant, and then type event handler like this. So now we are almost finished. Now I also want to create an event handler for the stop button. So when I click on the stop button, I want the program to stop. So then I go to the case event handler, and then just right click on the border here, add event case, and then I select the stop button, an event for value change. Click OK, and then this event handler has been created here. And then I just drag the stop button in here, and then right click here on the border to specify which case I should go to. Then I just right click, create constant, and then I should go to a stop case or an exit case or whatever name here. You decide the name, but you typically also need to create a new event here or a new case here in the in the case structure. So then I just right click on the case structure, add case after, and then I just name it stop like this. And then I can also right click here on the case structure border, select rearrange cases, and then you see now I have a case called initialize, I have the event handler case, and I have the throw dice case and the stop case. And I can also change the order here. This is the visual order, but I decide the order which the different cases should be executed. So this is just the visual order of the different cases. So we have initialize, event handler, throw dice, and stop. Then I just click OK here. So now we are almost finished. We know next we need to decide when the while loop should stop. So if I right click here on this small icon in the right lower corner, select. So this means that the while loop should stop if you wire a true to this symbol. So then in the initialize case, I just right click, select the boolean and a false constant, which I put here in the lower corner, and then I wire this boolean constant to this icon, because the while loop should stop when this value should be true. So now in the initialize case it should be false, and next case is the event handler case, and also here I just right click, create constant, and also here it should be false. The same for the throw dice, I just right click, create constant, and set it to false. And then finally in the stop case I right click, create, and select constant, and now it should be true, because when I click the stop button the program goes into this event called stop, and it goes to the case called stop, which is here, and then here I set this while loop to be the stop condition to be true, meaning the while loop stops and the entire program will stop. So basically now we are finished with the first draft of this application. I also here, you see here I have a broken arrow, meaning I have tunnel missing assignment to tunnel. So here in the stop case, here we don't need to go to another case, so then I just wire from the question mark to the right border like this, and now you see we have a running application, and then we have used this state machine principle with a while loop, with a shift register, with a case structure, with 1, 2, 3, 4 different cases, and one of the cases are called event handler, and inside the event handler case we have created an event structure which is used to react on different types of events. Typically when a user click a button like this throw button or this stop button. So now let's just start the application and let's see what's happening. So I just save it, click on the run arrow, and now I click on the throw button, and then you see every time I click here a value is generated, but there's something wrong. So let's see. So initialize, it should go to event handler, and here in the timeout it should go to just right click here. It when this 100 millisecond timeout is running out, it should go to just the same case, which is called event handler, like this. Typically also we want the event handler case to be the default case, so then I can just right click here and then select let me find here here make this case default, so then the event handler is the default case. So now let's see what's happening now when we run the application once more. So now you see it goes into this initialize case, set the dice value to be 0, and then I click here on throw, and then it generates a new value, meaning it goes into this case where it uses this random generator to generate a new number between 1 and 6. I can click once more. And now you see every time I click here it generates a new value between 1 and 6. And of course also here click right click on this line, select a probe, and then you see when I click here on the throw button, you see the code goes into this case handler and generates a new number every time. And finally, when I click on the stop button, the entire program stops, because then it first goes into the event handler case and the stop event handler, and then it goes further to the stop case, which has been created here, and then I set the while loop condition to be the while loop exit condition here to be true, meaning the while loop stops and the program stops. So basically this is a simple application where I have a numeric indicator, 2 buttons, and I have used this this state machine principle consisting of a while loop, a case structure, and in one of the cases I also using this event structure. Also, in order to illustrate the flow in the program, I can also turn on this highlight execution. I can turn it on, and then just select, I can here select slow, medium, fast, or very fast, and I select slow, so you can easily see the flow in the system. So now let's have the block diagram here and the front panel here, and then I just start application, and then you see it goes to initialize case, then it goes to the event handler case, and now since I haven't pushed any button, it just wait for 100 milliseconds, it goes into timeout, and then the next case here should be the event handler case, so it just wait here until I click a button. So let's see what's happening now. When I click the throw button, it goes to the throw dice and then to the throw dice case, and in the throw dice case this random generator generates a new number that it puts here into this numeric indicator. And then so every time I click on this button, it goes into the throw dice event and the case for the throw dice, and it generates a new number between 1 and 6. And then finally, when I click the stop button, it goes into the stop event and the stop case, and then this becomes true, and the while loop condition becomes true, and the entire program stops. So basically this is how you create a basic application using the state machine principle. And since I have used this state machine principle, you can easily extend your application with more features. And as you see in my first version in the PowerPoint, I was also including a plot or a chart. So let's see how we can easily extend this application with some plotting features. So then I just make this front panel a little bigger. I put the stop button here in the corner. Then I just right click, select graph and this waveform chart. And then I just put it here. Make it a little bit bigger, something like this. So now I have extended the application with a plot, and then I want to plot the value from the dice here in this plot. So then I can change the y value to dice number something, and then between indicating that this is a value between 1 and 6, like this. So now let's see how we can easily extend the feature where I just, in addition to showing the value from the dice here, also show the value here in the plot. So then here in the throw dice case, I can just right click. I can either add case after, or I can create the duplicate case. I choose to select duplicate case, and then I just remove the feature here, and then I name the case. I can call it whatever I like. I can enter plot data or something, and inside here I should plot the value that is presented here inside this plot. So then I just go to this numeric indicator, I right click, create a local variable, I just put it here, go to the plot data case, and then I put it inside here. I right click and then select change to read, and also find where this object for this chart. So I just double click on it and it's here. I put it outside the while loop, go to the plot data case, then I put it inside here. So then I just wire this local variable to the waveform chart like this. Now I'm almost finished. Then in addition, after I click this throw button, so the code goes into here, generate a new value, and then now instead of going to the event handler, I want to go to the plot data case. So then I just change the value here, plot data. So now after the execution of this one, it will go to the next case called plot data, which is this one, and then it will show the current value inside this plot. And next it will go to the event handler. So let's see what's happening now. I click on the run button, click on the throw button, and then you see every time I click here, I can also turn off this light symbol. You see everything I click on this button, it will show the current value here in the plot as well. I can also change some features here in the plot. So if I just right click on the plot, select, I can turn off auto scale, and then I can set the lower value to be 1 and the upper value to be 6. I can also click here on this to change the color. I can change it to some more red color. In addition, I can select interpolation. No, I don't want to have interpolation, so now I just select this one instead. I can also select point style. I can select this as a point style, etc. So let's just run this application now. I click on the run button, and I click multiple times to generate a new value on the dice that will be shown here, and also the history of previous values will be shown here in the plot. I can also right click here, select clear chart, and then a new value will be generated here and shown also in the plot at the same time. I can also change the value here on the x-axis, going from 0 to 10 or something. So then we see the value here. I just right click, clear chart, click on the button, throw the dice, and then you see Every time I click on the button, it shows the last value here, and it will show the historical values of the dice here in the chart. So then you see, using this state machine principle and creating applications in LabVIEW is very handy, and then it's becomes so much easier to extend your application with more features like this plotting feature. And when I turn on this light symbol, you can easily see the flow in the application when I run the application. So then now it go into initialize, go to the event handler, and then since I'm not clicking any button, it just goes here forever. I'm timing out after 100 milliseconds, then it goes into event handler once more, wait another 100 milliseconds, and then nothing happens until I click this throw button. Then you see it goes to throw dice, then further to the throw dice case, using the random number, presenting the value here in this numeric indicator, plotting a new value here in the plot, go back to the event handler, waiting for a new event, either a button click or whatever the application is doing. Now click the throw button once more, it goes into the throw dice here, generate a new value, go further to the plot data, plot a new value, and then back to the event handler case. Finally, I can click on the stop button, then it goes to the stop here, and further to the stop case in the case structure. This becomes true, and your application stops. So basically, this is a basic LabVIEW application where you're using this state machine principle.